So hello viewers and welcome back to another video on networking. So in last video we have seen the topic, or actually we are seeing the playlist on the topic, which is why we don't run out of IPv4 addresses, and these were the content that we have seen. So in first video we have seen the introduction, what is netting and patting overview. Then we started seeing the simulations in the Cisco Packet Tracer. We have seen the static net and dynamic net configuration. In today's video, we'll see the configuration of port address translation, or you can say patting. So without wasting much time, let's get started. Hello. So before we start actually the configuration part, the configuration is very similar to what we have seen for the dynamic net. So it's better to start with the theoretical part. So the solution for why we don't run out of IPv4 addresses, that is NAT and PAT, and the concept of public and private IP addresses. So what we have seen in the NAT, so NAT was the translation of just the translation, which is the translation of private IP address into public IP address, where you can see static net. In static net, what we used to do, we used to just translate one public you can say private IP address into public IP address. That is just NAT, right? But in practical perspective, we cannot have you can say one individual public IP address for all of our private, so for just one of our private IP address, because we were to have each individual private IP address to mapped with unique public IP address, then eventually we will run out of public IP addresses, right? So to solve that, we have something called PAT, right? And what PAT does is, PAT actually maps one single public IP address into multiple private IP addresses, and that is done using the pair of you can say IP address and the port number, which is mapped to the public IP address with the pair of you can say port address. So here you can see we have different private IP addresses and same port. So basically you can assume that all of these devices wants to access google.com. Now we have one public IP address only, but the difference over here is that the port number. So in outgoing you can say translation will also change the port number with the IP address, so that you can see we have unique pair of public IP address with the port number to private IP address and the port number. So that's how port address translation works, or you can say PAT, and that's how we call this port, because actually we are translating port also. So now let's see what happens in the practical you can say perspective, and how you can configure Cisco Packet Tracer, how you can configure actually PAT in the Cisco routers. So here you can see we have this topology that we have seen in the last two videos. So first we have seen the how to configure static netting. Then in the same topology we have seen that how to configure dynamic netting. Now from the configuration perspective, the configuration is very much similar to dynamic netting. So I have actually configured this entire topology with the patting, and to do so, what are the changes that I did? So you can observe over here in the you can say show running configuration. So, and in order to do that, from the user privilege mode, I can just hit show run. That is shorthand for show running configuration. And you can see first we need to configure the pool of private IP addresses, and instead of giving start IP address and you can say end IP address, we have kept the start IP address and the end IP address same, which is 10.10.100.2. If you remember in last video where we have configured the dynamic netting, we have used actually the different start and end IP addresses. So that is the first change. After that we have given the net mask, and here we have created an access list to permit basically the private IP addresses. And now if we want to connect if you want to make the patting rule, how we have did is IPNet inside source list. So here we are mapping this entire list with the pool of public IP addresses, and after that last keyword which is we are using, which is overload, and this keyword overload will make router know that we want to use the port address translation, and rest of the configuration are same. IPNet inside is 8 fast Ethernet 0/0 and IPNet outside is fast Ethernet 0/1. Now let's observe one packet. So we enter simulation mode, we take one packet, and now we send from this device to private IP address. So first of all, real time, okay, it failed, but yeah, we can just hit again. Yeah, the packet is successful. Now we can enter simulation mode. Okay, first of all, I will send one packet from this device to laptop to server also, which is successful. So yeah, so we'll send one packet. Now again we'll enter simulation mode, we'll take one step ahead, and now we will send one packet from laptop to server. Now you can see this packet is going. So you can see inbound source IP is 192.168.10.2, but the outbound is 10.10.100.2, and you can see sequence number is over here is 5, and over here it is 5, same. Okay, so you can see this is the packet. Now if you enter the OSI model, you can see the rule, the NAT rule applied over here. So you can see the packet is going from inside to outside, and the device has NAT configuration. So the packet matches the inside source list, so the source list accesses that we have created, and create new entry for the source local address, and the device translate the packet from local to global. Now to see the changes, we can actually observe the NAT table. You can see, okay, there are a lot of packets. So you can see 2.5, which is translated to 192.168.10.2:5, right? And there are a lot of you can say entries. That's because we have actually sent so many packets before. So now over here also we can see packet. So this packet is coming from laptop and going to router, going to server. So you can see the translation happening. So the inbound source IP is 192.168.10.3, but the outbound source IP is same for what we have seen for this packet. But we can actually before seeing the NAT table, we can see the rule being applied over here. Same rule applied. Now we can actually again check the NAT table. So you can see 10.10.100.2 and the port number is 1025 is translated for 192.168.10.3:2. So we can again go over here, packet inbound. You can see sequence number is 2, but over here sequence number is 1025. So that's how the packet is translated. Now we can again check the translation, reverse translation actually. So inbound source IP is 10.10.100.20 and the destination is 10.10.100.2 with the sequence number 5. Now let's see what is the entry with 100.2 and sequence number 5. So to do that, we'll observe NAT table. So you can see 10.10.100.2 with sequence number 5, so which should be translated to 192.168.10.2 and the sequence number 5. So let's observe the packet. Let's observe outbound. You can see 192.168.10.2 with sequence number 5. So that's how the NAT rules are applied. We'll again check for this packet. So you can see destination IP is 10.10.100.2 with the sequence number 1025. Now let's see the NAT table for that specific entry. So you can see 10.10.100.2:1025, which should be translated to 192.168.10.3:2. So let's see if it is translated properly. So yeah, we can see 10.3 over here and the sequence number 2 over here. So that's how actually NAT works. and that's how you can configure actually port address translations. So I hope you have got the idea about how you can configure patting, or you can say PAT, on the Cisco routers, and what is the difference between NAT, PAT, static NAT, dynamic NAT, and patting. So, and now I think you are clear that why we don't run out of IPv4 addresses. If you still have any doubts, you can ping me in the comments. And by the way, that's it for this video series. uh, we will see in the next video. We'll explore more networking topics, and if you have any suggestions for that also, you can feel free to actually drop a comment and let me know what topic should I cover for the next videos. And I think that's it for this video. We'll meet in the next one. Till then, keep learning and keep exploring.